So we're going to start with a thought experiment. Imagine for me, if you will, that you are studying a postmortem. You're like, I know, my redaction job, it's beautiful. Imagine you're reading a postmortem or studying an RCA or incident documents or whatever. You're trying to identify patterns in your outages. You want to understand more completely why certain classes of incidents keep happening. You take some time, you look at how long it takes, you look at the dependencies, you look at all of the fields we see there, and eventually you get kind of a sense of it. Then you have to read another one, and it takes maybe the same amount of time. Maybe it's related to the one you were looking at before, maybe not. Either way, you've got to read another one, and another one. And eventually, well, you kind of burn out a little bit. The reality is this is difficult to do. It's time-consuming, and humans make mistakes. You know, if you have to go through that many postmortems, you're not going to capture all the information that's in them, and you're not going to glean all of the insights about what your service could be doing better. So what do we want to do? Well, we want to make the robots do it, right? So imagine again. A world at which we can learn from failure at scale, automatically. Your trends are just magically identified. The anti-patterns just quash themselves. They just disappear. And the reliability work, it's appropriately prioritized. Right? It's beautiful. It's a wonderful dream. Any of us who have had to deal with this know. And well, it gets the data scientists excited too, because this is where the real meat of ML can come in and make a difference for your service. I work in problem management. Another way to say that might be that I help Azure learn from failure, because a broken cloud doesn't empower every person in every organization in the world to do anything any better. And problems, as we're going to use it in this conversation, are just the cause of one or more incidents. I have some issues with this definition, but I'll come back to them later. But in the context, we're talking about that. Problem management, learning from failure, making sure that whatever happened this time doesn't keep happening for the next 3 years. And so this has been my dream. I want to do this automatically. Our services are scaling at an insane rate. Azure is just huge, and we're not going to be able to keep up. So I want to take you back to when we first started trying to do this sort of stuff. Our first steps in trying to do some automated learning from failure. And hopefully you can learn from the mistakes we've made along the way, as well as learn some of the insights we derived. When we first got started, I kind of assumed you would just do the typical thing, kind of like you do for Kaggle, if we're being real. Right? You gather some data, you select your models, you train those models, you evaluate how well those models did, and you set them loose, right? But that's not the hard part. We've got lots of smart people that can do that. The hard part is knowing what you're actually looking for. What it is, you can't just take your repo of postmortems and say, ML, go. It just doesn't work. So I figured, but I didn't realize at the time. I thought, well, I don't know, we'll just throw some models at it and we'll see what happens. And we'll get, I don't know, something amazing. We'll get some insights about what's going on. But we were coming at it from the fundamentally wrong angle. We were looking for root causes. We had a root cause taxonomy problem, right? Whether or not something fit into one category of root cause or another. Here's an example of an early attempt we made. This is all very old stuff at this point, where we were trying to build a taxonomy of categories and subcategories of root cause, and then we would be able to look at the postmortems and bucketize them appropriately and use ML to do that, and it would be great. But that's just not how it works, because complex systems fail in complex ways. Right? I can take a quote here from something called How Complex Systems Fail. It's from a cognitive technology laboratory at the University of Chicago. It says, each of these small failures is necessary to cause catastrophe, but only a combination is sufficient to permit failure. In the last talk, we heard about death by 1,000 cuts. In reality, complex systems have layers of defenses. The human defense, you've got your testing, you've got your deployment pipeline, you've got Canary, you've got all this other stuff, or at least you're supposed to. And customers should only feel pain when it penetrates all the defenses, when a combination of faults happens at the same time, when you have all of these contributing factors that penetrate the defenses. So a single root cause just doesn't really make sense, does it? You're just looking at like the butterfly flapping its wings and you blame that for the hurricane, but that's not actionable. So let's take a step back and let's think, why do we actually do RCAs? What is the point of doing root cause analysis? You want to stop the bad stuff from happening again, right? Root cause analysis fundamentally is not about the past, it's about the future. It's about keeping your services from failing. That's the whole point. And if no one reads them and if no one takes action based on them, then there was no point to do the analysis. So we figured we'd go hunting for contributing factors. And for the purposes of our study, we defined an outage as this, right? A service or platform level issue that impacts customer experience. There are lots of other smaller incidents, as we call them, but the ones we wanted to measure for this, for simplicity's sake and for sanity's sake, were the ones where all of the defenses were penetrated, where the customer impact happened. We figured if we can find the contributing factors that tend to show up when things actually break and the customer sees it, we'll know what work to prioritize and what to fix first. And so we started with postmortem text analysis. Probably not the best place to start. But this was the stack we used just for the curious. And this is some example result. There's my beautiful redaction job again. Just to give you an idea kind of how this works, you've got your clusters of outages essentially. They're grouped together. On the left, you see there's kind of a closeness between different groups of postmortems and thus groups of failures and failure classes. And then on the right, you've got the list of the most common terms that were associated with that group. And so when you look at that, in theory, you can kind of understand within this group of issues, we see a lot of these specific terms, which tells us that this class of thing tends to happen a lot. You can go through several iterations of this where you start whitelisting certain words or blacklisting certain words, or what we use Beautiful Soup for was just get rid of all the HTML that ended up in things. But honestly, when you get to this point and you have this list, it's still not actionable. I mean, it really isn't. I mean, look at that. You got here's some buckets, and here's the list of words that are in that bucket that are really big. It's just like handing someone a word cloud. You really need to know which ones are a big deal. And how do you do that? Well, you use metrics, right? These guys. That seems like a reliable way to do things. I'm going to give you an example of what we decided to use to help make sense of these different buckets to help the decision makers prioritize what work needs to be done first. And we used what's called the pain value. And the equation is roughly as such, right? Number of outages times their duration, times their severity, times a weighting factor. That's the general principle. And I'll give those who are taking pictures a second for that. But I will come back to the slide in a sec. That weighting factor is an interesting one because it's a way for you to customize this specifically to your services. The weighting factor, you might say, could be an SLO, for example. Or if you need more ideas, here's a list. The number of customers impacted, the number of regions involved, the number of different hardware SKUs, the distance below the SLO, or the number of SLOs that were breached. All of these could be ways you use your weighting factor. Which, okay, now we're cooking with fire, right? Now we have something quantifiable, something we can prioritize and have a very clear backlog of do this now and save this one for later. Here's that list again. So, seems like it makes sense, seems automatic, right? Seems like now we can just let this loose and it will prioritize things for us, and we can start to add in other data sets and just make it more rich and defined, but not entirely. Human interpretation is still necessary even at this point. And this is one of the fundamental things you want to understand when you want to learn from failure and you want to start automating it and you want to do it at scale, is you have to move up this pyramid, right? You get your raw data, you process it into information, which just makes it a little more understandable. When it gets to the point of being knowledge, it's actionable. And with wisdom, you know what things you should act upon. So what we did with text analysis is we took data and we took it roughly to the point of knowledge, depending on how pedantic we want to be at the definition. But to do this fully automatically, you want to get to wisdom. In this first iteration, we couldn't do that. One of the reasons we couldn't is hinted at in the title of this talk, right? Our data. It was not clean. It was not good. And when you have bad source data, your models don't mean anything. You can run them and they will just lie to you. So rather than count you all the ways our data was specifically broken, because probably I get in trouble for that, I'm just going to count some of the ways your data can be broken. And if you've ever seen this issue with your data anywhere ever, Maybe raise your hand, and we'll go through a few of these. So missing data. Data sets that just don't exist. Postmortem's not completed, for example, among other things. Maybe a few. Have you ever seen this on a chart? I hate this. I'm going to go gray early because of this. Inaccurate data. Please tell me. Don't lie to me and tell me you've never seen something like this. Someone makes an assertion or an analysis and it's just not true. Irrelevant data. This one is really hard for machines to distinguish because common sense is a very advanced AI topic. Let's just put it that way. Something for text analysis specifically is ambiguity. Right? I mean, here's a bunch of definitions of node. If you can think of more definitions of node, please send them to me because I want to make this slide bigger. But if it buckets all of these same things together, then you've got Node.js and Bitcoin miners in the same bucket. That makes a whole lot of sense. Confounding factors like config drift. All right, we're going to do the inverse this time. Raise your hand if you honestly think you've never had config drift in your environment ever. That's what I thought. So your models have to change, because if your models are trained on your environment having a specific configuration, and then you deploy something new, you're not talking about the same environment anymore. You need to go tuning things as you go. And of course, just humans. We misspell things, we fat finger things, we're just wrong button pushing beautiful disasters, aren't we? So, dirty data, it will lie to you. It will set you back, and it will take a whole lot longer. When you can go back and you can clean it up, or at least get it to a reasonable level of quality, one of the measures we use is called signal bars. Right? So when we present data, we can show how confident we are in the data based on its quality. We're not quite at AT&T and Verizon levels yet, but we're getting there. Then you can give the decision makers a little more context on how much they can trust this. So what were some of the results we found? I can't give you specifics. I can't air Azure's dirty laundry for you. But I can tell you that we had some surprise issues surfaced. Even with the data quality issues we had, we were able to go back and human verify that there were a couple things that they never showed up in live site review meetings. They didn't show up in the conversations people had, and they weren't in anyone's priority backlog. Well, they were a huge amount of the customer pain we were feeling. They were a huge amount of the total suffering inflicted on our users. Conversely, we debunked a bunch of production myths. I'm sure all of you have at least once heard some executive railing on something that they think is wrong that isn't actually that big of a deal. We were able to validate some of that. Even something that I thought was a big deal, because I do crisis management, which is just our name for incident command for all of Azure. There were things I thought, man, this is a huge pain. This happens all the time. This has got to be really, really frustrating people. But honestly, compared to the other stuff we saw, maybe it wasn't as high of a priority. And again, when you have these numbers, when you have a pain value analysis, or if you have, like we're going to have talked about tomorrow, if you can quantify the risk involved with your services and with certain failure modes, then you can legitimately prioritize and compare one against another the sort of work that needs to be done to fix things. So what did we learn in general? Well, you need to define your hypotheses. You need to know what you're looking for. If you're looking for a specific root cause, it's the wrong paradigm. If you're looking for contributing factors, which as a plurality make things happen, it's a little bit better. Similarly, I mean, this is the case for all ML, but especially if you want to learn from failure. Second, clean your data, otherwise your output's as garbage as your input. And 3, you need to work your way up the data, information, knowledge, and wisdom pyramid. Right? The further up you go, the more automated things can be, and the more you can trust them. So what else can we do, and what else has Azure been working on in the interim since this time? Well, you can cross-correlate your data sets. There's a lot of potential here, right? I mean, we talked about postmortem analysis and all that cool stuff, but you can compare it with your metric data, and you can, if you've got these themes and you've been able to extract them, you can compare those timelines for those themes with your metric data and start to see things coming before they happen. Similarly, with minor failures, right? I talked about how we were only studying the incidents that ended up breaching SLO and making our customers suffer. But we have minor incidents all of the time that just don't make it through all of the defenses. But usually when you have a major outage, there's a surge of minor outages beforehand. And so if you can study those and understand those, you get into a lot of preventative measures. And you can stop things from ever being a problem rather than being a problem once, which you then fix. And then intelligently calculate risk. Again, I think we're going to have more talks about that tomorrow. But if you can quantify the risk, there's a nuance there between risk and pain value, right? Because the pain value is how much suffering this causes when it happens, and the risk is how likely it is to happen. Because if you've removed that firmware from rotation, for example, then no matter how painful it was, it's just not going to happen again. So you need to put these things in context. And at the heart of this all, even for those who haven't really automated a whole lot just yet, continue to improve your RCA process, right? You auto-populate fields where you can. You present whatever metric data you can, snapshots maybe from the time frame of the incident, to those who are going to be doing postmortem analysis because, well, they're going to need it anyway, and otherwise they're going to dig through it, and eventually you can get to the point where the humans don't have to write the postmortems because production can tell us what's wrong. And that's ultimately the goal, right? We want production to tell us what's wrong. That's the dream. We want our systems to learn from themselves, and we want them to learn from their mistakes. Because honestly, these systems are not going to get any less complex. They're going to keep growing and growing and growing. This industry is just insane. And if we have any dream of keeping up, we can't scale this humanly. We need to do it automatically. And I personally plan to blast off right behind them. So my name's Tanner Lund. I work for Microsoft Azure SRE. And this has been Learning at Scale is Hard.
Got a couple of minutes for questions?
Yeah, we've got about 4 minutes, I think, for questions.
I'll start you off. So I know that you said that your data was dirty and that's a big problem, but do you think that there is much that you learned from that exercise that you couldn't have learned by having some sort of a structured way to associate each outage with a set of bug or ticket numbers and doing an analysis of which bugs and ticket numbers are occurring most frequently with major and minor outages?
So the line between one bug and another bug is human defined, correct?
Correct. Yes.
Or the line between one ticket and another ticket.
Yes, when very much assumes that people are deduplicating.
Precisely. So so yes, absolutely. By having, even though it was dirty, having less structured data meant we made less assumptions about what the data should tell us. How do you know if one incident is a repeat of an incident, or its own incident, or the same incident that you never properly got straightened out? And so, while it certainly would have saved us a lot of time, it also kept us from making assumptions maybe we shouldn't have. I think we've got one over here.
Yeah. My question is, once you reach beyond knowledge, all the way to the wisdom level, at that point of time, how does your learning experience feed into building better self-healing primitives into the system so that majority of the situations that arise get handled as much as possible automatically and improve uptime, availability, all that kind of stuff?
Okay, well, I'll answer it the best I can, because honestly, someone who can do that exactly right probably deserves several PhDs and maybe a Nobel Prize. But what you can do is if you can get your data to be trustable enough, then you can have an authoritative backlog for your various services. And you can have this system cutting the bugs and cutting the recommended work for them. And maybe a human can go and add in a little more details about how they're going to implement it. But the concept and the problem space that needs to be solved can be very clearly defined right there. And then just as you would with anything that's already been greenlit or however you do your planning process, you just go and execute.
This is clearly an area where things are going to be different in 12 months' time and hopefully very different in 5 years' time.
Absolutely.
Is there anything from the work you've done that you can open source?
Anything from what we've done so far that we can open source? Well, probably we could, depending on how you do your postmortems, we could probably open source the way we're doing the text analysis and the way we've tuned it to handle things that are related to outages and your tunings of certain lambda parameters as well as the whitelist and blacklist sort of things. It would still need a little bit of configuration, but that's not a bad idea. All right, I think we're out of time. If anyone has more questions, feel free to chat out in the hall. And as always, we're hiring. Thanks.